Today's topic is symbol table, which is useful in each and every phase of compiler design. Coming to the definition of the symbol table. Symbol table is a data structure used by compiler to keep track of semantic of variables. That means symbol table. It stores the information about scope and binding information about names. Not only that, the symbol table is built in the lexical and syntax analysis phase. In the lexical analysis, the source code is going to be dividing into the lexemes and identifying or recognizing the keywords, identifiers, literals, all are stored in the symbol table. Based on the symbol table reference, the syntax analysis phase is generated. The symbol table is used by various phases as follows. Semantic analysis phase refers to the symbol table for conflict issues. And code generation refers symbol table knowing how much runtime space is required or allocated. What type of runtime space is allocated? If the value L value and R value. The L refers to the left and R refers to the right side assignments. Based on the assignment, for example, A equal to I plus 1. A will be the left value and I plus 1 will be the right value. Of this symbol table, the identifiers, literals, and operators, operands all will be stored in the symbol table to generate the different phases, and it will be useful in every phases to complete the tasks. Let's come into the symbol table entities. To achieve complete time efficiency, compiler makes use of symbol table. So if you are not maintaining the symbol table, it not get the information properly. That means where it is going to be stored means it is going to be stored the all the letters, identifiers, keywords, constants, all will be stored in the symbol table. It will helps to making the time efficiently in the further compiling process at the time of compiling process. It associates the lexical names with their attributes. The items to be stored in the symbol tables are variable names and constants, procedure names, function names, literals, constants, and strings, compilers generated temporary variables, labels in the source program. All are to be stored in the symbol table with the references. Based on the references, in the each and every phase, it is going to be accessing. The compiler uses the following type of information from the symbol table, like data types, names, declaring processor, offset in storage. If structures are records, then pointers to be structure table. For parameters, while parameter passing is by value or reference, all to be stored in the symbol table. Number and the type of arguments passed to the function and base addresses are going to be stored in the symbol table. All these informations are stored in the symbol table and utilized while each and every phase of compiler. Next, types of namespaces, or we can say the how to store the names in the symbol table. There are two types of namespaces. One is fixed length and another one is variable length. A fixed length space for a name is allocated in symbol table. In this type of storage, if the namespace is too small, then there is wastage of space. That means we are going to be allocating that A of 10 and we are going to be utilizing the only the A of 5 characters. The remaining 5 are to be the wastage. We are not able to unable to allocate the remaining space to other. For example, We consider that it contains the name and attributes. And the fixed length array. It refers to identifiers informations are to be stored in the table with the names and their attributes. The name can be referred by the pointer to the symbol table entity. Next, we have the variable. Like that, it is going to be considered. Here we given the boss and Srinu. It has to be stored in the fixed length variable. Here the name and information has to be considered. The name is stored as REENU, Srinu, and boss. The remaining here we have in the spaces 1, 2, 3, 4, 5, 6, 7, 8. Instead of 8, the remaining 2, here we have the 2 blanks or wastage of space. Here we, in the next we have the boss, BOSC. Here the blank spaces are 4. We are not able to utilize the blank spaces. So that here we are going to getting the wastage of space. Next, variable length. The most of the space required by the string is used to store the names. The name can be stored with the help of starting index and the length of each name. Let's say whatever we considered in the above. It is to be taken identifiers 1 and identifier 2 with the length of identifier. Here we have the length, total length SREENU 1, 2, 3, 4, 5, 6. Here the length is 6. Here the length is 4. There is 6 characters and 4 characters. Yet we are going to maintain the index, starting index 0 with the length 6. After 6 we are going to get 7. The length is 4. Adding that and next is we are going to get 14. Like that we are going to be getting the different values. Right? Next, the symbol table management. The symbol table management requires requirements for the symbol table management. For that, the first is for quick insertion of identifier and related information. First, what we are going to do, we're going to be inserting the identifiers and related information in the symbol table. After that, the quick search of the identifier. We're going to be searching for the quick search for the identifiers. Following are commonly used in the data structures for the symbol table constructions. In that, we have the first one is list data structure for the symbol table. Second is self organization. Fourth one is organization list. Fourth one is hash tables. Now coming to the first list data structure for symbol table. In this, we have the linear list is the simplest kind of mechanism to implement the symbol table. In the symbol table, in this method, an array is used to store name and associated information. Right? In the previous one, we have seen that. Like that, in the name and the information has to be stored. New names can be added in order as they arrive. So based on the arrive, this is going to be added in the list. The pointer variable is maintained at the end of all the stored records. For the list data structure using arrays. To retrieve the information about some name, we start from the beginning of array and going on searching up to available pointer. If in case if we search a point available without finding a name, we get an error. Use of undeclared name. If it is not found means we are going to get error and it is showing that the use of undeclared name. While while inserting a new name, we should ensure that it should not be already there. That is, we have to such that whether the given name, inserting name is available or not. If it is not available, then we can insert. Otherwise, we have to change the name. Otherwise, it will get then an error occurs. There is multiple defined names. We are going to be inserting or adding. It is showing that the multiple defined names. Under the self organizing list. This symbol table implementation is using linked list. A linked field is added to each record. We search the records in order pointed by the link of link field. A pointer first is maintained to point to the first record of the symbol table. But here we have the name and information like that. The first we're going to be pointing this to the name 3. In that name 3 we have the name 3 and data name and link 3. Link 3 is pointing towards the name 1. In that we have the data and the link is pointing towards the 4. In the 4 we have the name, data and link. Link is finally it is going to pointing towards the 2. Like it is shown like this in the mechanism. Initially it is going to be stored pointing towards the 3. So that 3, 3 2 it is moving to 1 pointing towards the 1. From 1 it is the link pointing towards the 4, then 2. After 4 name is required, so that move the fourth to front. That is, we are going to moving the fourth to front. So that 4 3 1 2. We're going to be adjusting the connections self-organized. We're going to be adjusting the connections. So that we're saying that self-organized. So finally we're going to get 4 3 1 2. Right? Look here 4. First we are going to get here 4 3 3 2 1 1 2 2. Based on this movement, we are going to get the finally we are going to get this. Next, we're having the hash table. Hashing is an important technique used to search the records of symbol table. This method is superior to list organization. Right? In the most of the data structures, we are saying that hash table is the better for the searching. In hashing scheme, the two tables are maintained, a hash table and the symbol table. Here in the hash table, it consists of k entries from 0 to k minus 1. All these entries are basically pointers to symbol table pointing to the name of the symbol table. Right? We're having the hash table having the pointer pointing towards the symbol table point, name tables. To determine whether the name is in the symbol table, we use the hash function h. For the hash table, we are going to using the hash function h. For such h name will result any integer between 0 to k minus 1. That means the symbol table name will be stored between the 0 to k minus 1. We can search any name by position equal to h name. Right? Using this position, we can obtain the exact location. We can obtain the exact location of name in the symbol table. The symbol, the hash table and the symbol table can be shown below. Shown in the screen here. Here we have the h name. Here we have the hash tables 0 to k minus 1, and it having the pointers pointing towards the symbol table. Sum, I, j, average in the symbol table. The as function should result in uniform distribution of the names in the symbol table. It is going to be distributing the names in the symbol table. The as function should be such that there will be a minimum number of collisions. Collision in is such a situation where hash function results in same location for storing the names. When we get the collision means when we are storing the value in the same location, right? In the symbol table, at that time we're going to get the collision. The various collision resolution techniques are open addressing, chaining, and rehashing. To avoid the collision, we're going to be using these techniques. What are those? Those are open addressing, chaining, and rehashing. Right? The main advantage of hashing is quick search is possible, and the disadvantage is the hashing is complicated to implement. Some extra space is required. Obtaining the space of variable is very difficult. That is about the symbol table and runtime storage in the concept. We're having the symbol table. These are the different techniques we are going to be using to store the data in the symbol table. I hope that you understand the concept of symbol table, why we are going to use, and where it is going to be utilized, and how efficiently we are going to be utilizing the different techniques to make the compiler fast.